Hello guys, welcome to Yebo Physics on a Thursday afternoon. My name is Arnold and I'm going to be joining you this afternoon, and we are going to be solving physics problems together. I hope that you are going to be joining in numbers or watching this video later on if you have missed the live session. So once again, it will be a pleasure to have you interact with us here in the studio so that we may get the necessary feedback, which is important to us in contributing to your learning as well. So feel free to unmute your mics. If you are joining on Teams, feel free to unmute your mic and share with us. Could be a comment or a question. If you are joining live on YouTube, also make a comment in the chat box and we will be able to see it and we can interact with you. So we are going to be solving questions from tutorial 3, that is on for the guys doing PHYV 101, and the questions are on Moodle, and we're going to be solving questions 6 to 10. If you have missed any of the questions that were worked out earlier on, please do check the recordings that were made. So we're going to be starting with question 6, then through up to question 10. Then later on, we're going to solve selected questions from the FPV 101 physics workbook. So we're going to be starting shortly with the questions on our Moodle site, where we need to start with question 6. Already we can see on the screen it's question 6 that is displayed there. I'm just going to put it up so that you can see. So this is indeed question 6, and we intend to solve that problem. So we are on the chapter on application of Newton's laws of motion. All right, so like I said, if you have missed any of the questions, find the recordings on the YouTube channel. If you're joining in on live on Teams, feel free to unmute your mic and share with us your comment or question. We would love to hear your contribution. Okay, if you cannot unmic or if you cannot unmute, then you can actually type in the chat box. We will be able to see your comment or question in the chat box. All right, let's get started because there's going to be load shedding later on. So let's get started and solve the problems together. So what do we have on the first part of the question? On the first part of the question, that which is question 6, so I'm going to highlight that we are working on question 6. It reads a mass of 1.5 kilogram and a 1.5 kilogram object has a velocity of 5 meters per second in the j direction. That is at time t is equals to 0. It is accelerated at a constant rate for 5 seconds, after which it has a velocity of 6 meters per second in the I and 12 meters per second in the j. Then the question says, what is the magnitude of the resultant force acting on the object during this time interval? So we can write down quickly the data that we are given, then we can select from there what we intend to use. So our initial velocity, I'll denote it as a u, which is equals to 5 meters per second in the j direction. That's 5 meters per second, and that's it. T is equals to 0. It is accelerated at a constant rate for 5 seconds. So actually what we're looking for, what is the magnitude of the resultant force? Okay, so we're given time, which is equals to 5 seconds. So it's a 5 as well. So our time is 5 seconds as well. What else are we given? After 5 seconds, so our final velocity, it's 6 in the I plus 12 in the j. meter per second, because this is velocity. What is the magnitude of the resultant force? So the question is looking for the resultant force. Right. So since these are applications of Newton's laws of motion, so a body will remain at rest or continue to move in a straight line unless an external force acts on it, right? That's Newton's first law. Then the second law states that to every resultant force, or for every resultant force, there is an acceleration. So we are being asked to calculate resultant force, meaning that this object is definitely accelerating because there is a resultant force. So we also do not know what the resultant force is. Oh, another thing that we're given is the mass. So m is equals to 1,5 kilograms. 1,5 kilograms. So that is m. Okay. And from what we've just said, the magnitude of the force is equals to mass times the magnitude of acceleration. So the only thing that is constant there is that doesn't change actually in this equation. For an object, it will be the mass, and force and acceleration are directly proportional. So we can see that we have been given the initial velocity, the final velocity, and the time, which means that these three quantities can help us find this quantity. And when we find acceleration, we can then find the force. Okay, I think you can no longer see what I am writing there. Let me just see what the problem is with the screen. Okay. Just a moment, I am having a challenge with my screen. You currently cannot see what I am writing. Let's see if you can see. Yes, you can see, but I'll minimize that. Let's see, how is that? I think. So this is what I've been writing, while at least you couldn't see what I was writing. Apologies for that. So we have identified the equations, the quantities which were given in this question. We have realized that we have got initial velocity, we have got the final velocity, we also have got the time. Meaning to say, with these three quantities, the first three quantities that we've listed there, we are able to calculate the magnitude of the acceleration. And once we manage to calculate the magnitude of the acceleration, what that means is for every accelerating body, there is a resultant force. So once we get the acceleration, we are now able to calculate our resultant force. All right, so let's get on to it. We know that acceleration is equals to the change in velocity all over the time. That is our acceleration, right? So that is going to be our final speed. So our acceleration is going to be equals to 6 in the I plus 12 in the j minus the initial speed, which is 5 in the j all over 5. So acceleration becomes in the I, it's only 6 in the I. Then for the j, 12 minus 5, that will give us plus 7 in the j all over 5. So our acceleration is going to be 6 over 5. What is 6 over 5? 1.2, right? Just to be sure. So we have 6. So that will be 1.2 in the I plus 7 divided by 5. 7 divided by 5. That will be plus 1.4 in the J. This is our acceleration, okay? So what we need now is to find the magnitude of our acceleration, because we have this acceleration in the I direction and in the J direction. So how about we find the magnitude, which we can then use to find the what? The resultant force. So let's find the magnitude. So that will be the magnitude of A being equals to, by now you should be familiar with how we find magnitude, 1.2 all squared plus 1.4 all squared. All right, so let's work that out. So this is what we're going to have. We clear that. That is 1.2 all squared plus 1.4 all squared. So we'll get 1.844. 1.844. That is our magnitude for A. And we have mentioned that for every accelerating body, there's going to be a resultant force. So now we can find the resultant force, which is the mass is 1.5 times the acceleration, which is 1.844. So we then say our answer times 1.5. We get 2.76. That becomes the magnitude of our force. Okay, so just to summarize what we've just done there, we appreciated that we are looking at Newton's laws of motion. For every accelerating body, there is a resultant force. We realized we had an initial velocity, which was initially only in the J direction. And after 5 seconds, we have got our initial velocity, which is now in the I and also in the J. So we calculated the acceleration, then we realized the acceleration is in the I and it's also in the J. Then we calculated its magnitude, or the resultant, okay, of the contribution of I and J. We found the acceleration, we found the magnitude of the acceleration, then after that we did find the resultant force. So basically that is what we did on question 6. So we do have an option of 2.8. So that was indeed the expected answer. Let's move on to question 7. If there are no questions, if there are any questions, please do let me know if there are any questions. So far, I do not see any questions on the chat, both on Teams and on the YouTube channel. Question 7. A 2-kilogram block slides on a rough horizontal surface. A force of magnitude 4 newtons acting parallel to the surface is applied to the block. The magnitude of the block's acceleration is 1.2 meters per second squared. If P is increased to 5 newtons, determine the magnitude of the block's acceleration. Okay. So what do we need to do there? What do we need to do there? What do we need to do? So we are on a rough surface. So we can make a sketch, I think. Yes. So we can make a sketch. That is our rough surface. Then we have got a 2 kg block which is sliding on a horizontal surface. So this is our block with a mass of 2 kilograms, and it's sliding through a horizontal surface with a force of 4 newtons. So we have got a force of 4 newtons. What else do we have? The magnitude of the acceleration is 1.2 meters per second. So the acceleration is A is equals to 1.2 meter per second squared. 1.2 meters per second squared. Okay. So obviously, since this is a rough plane, we are obviously going to have an opposing force, which is friction, which is going to be opposing. Okay. So now how do we deal with that? Case? How do we deal with that case? Again, Newton's law of motion. Remember, F is equals to ma. And now we've got summation of forces. So summation of forces is equals to ma. So this is going to be our guide in solving this problem. Okay, this will be our guide. So we've got to sum all the forces acting in this system. And already, since this body is accelerating and the acceleration is positive, it shows that we have got a resultant force after subtracting our frictional force. So let's sum the forces. Let's sum the forces that we have in that diagram. So the forces that we have in that diagram, we've got the 4 Newton force, we've got the frictional force. Alright, and the 4 Newton force is the driving force, which is in the direction in which our block is moving, and the frictional force is acting in the negative direction. So when we sum these two, it is going to be 4 minus the frictional force equal to ma. Then from there, we can actually find the frictional force. We can actually find the frictional force by making the frictional force the subject. So it's going to be 4 minus what? Minus our ma, right? 4 minus our ma. This is equals to our frictional force. Then we can substitute 4 minus the mass, it's 2, the acceleration, it's 1.2 equals to the frictional force. So our frictional force, we can then compute that using our calculator. That will be 4 minus 2 by 1.2. So we get a frictional force of 1.6 newtons, which is important to find because we going to change the driving force now. So the driving force, we're told that now it's increased to 5 newtons. So 5 newtons. And we're now being asked to determine the block's acceleration. All right. So what do you think? What do you think is going to happen? What will happen to the block's acceleration? Do you think it's going to be large or small? Is it going to be larger than 1.2 or smaller than 1.2? What do you think? We've increased the driving force. So we're still going to maintain this same equation to solve our problem. Okay, because now we have the frictional force. Now we have the frictional force. Now we have the frictional force, which was the unknown that we had earlier on. Okay, so what do we do there? What do we do there? What do we do there? No, the driving force is now 5. That becomes 5 minus the frictional force equals to MA, which becomes 5 minus our frictional force, which we have calculated. It doesn't change, it remains 1.6 minus the M, the mass, which is 2 times A. So this will be 5 minus 1.6 over 2 equals to A. So A is going to be A will now be 5 minus 1.6, and we have our answer divided by 2. We get an acceleration of 1.7 meter per second squared. So that becomes our acceleration. That becomes our acceleration, 1.7 meters per second squared. Okay, so what did we do? Just to summarize what we did there, we appreciated Newton's second law of motion to say for every accelerating body there is a resultant force. So we sum the forces that we have, we equate them to MA. Alright, so basically that is what we did in solving for that problem. So we were told that this is a block, this block is moving on a horizontal rough surface, and meaning that there is going to be frictional force. So we had to calculate the frictional force. The frictional force is independent of the force that is applied. Okay, so we had to use the set of first conditions that we had to find the frictional force. Then we use that frictional force to calculate the magnitude of the acceleration when the driving force of the push has been increased to 5 newtons. So as we can see, when the driving force is increased, the acceleration is also going to increase. Why? Because the resultant force will have increased. Therefore, acceleration will also increase. So remember that force is directly proportional to acceleration. Okay. So that is how we solved, or that is how we have solved question 7. Hello, Tsepo, how are you? I see you're joining live on Teams.
Teams.
Thank you for joining. Can you confirm if you can see the screen on Teams?
Yes, I can.
Oh, that's good. That's good. I'm glad you can. So we've just been solving questions on the model for PHYV 101, that is applications of Newton's laws of motion. And basically the concept is still similar to FVV 101. So would I know which group are you in? Are you in the FVV or PHYV 101?
I'm in PHYV 101.
Okay, so that's great. So that is how we've solved question 7. Did you manage to comprehend what we have done so far?
Yes, sir.
Okay, great. So let's move on to question 8. I hope that those who are not able to join the live session will find this recording live on YouTube, and I hope that it is going to add to their learning. So question 8 says a book resting on a table. A book is resting on a table. How many forces would be in the free body diagram of the book? Okay, so this is question 8. Would you want to try that one? So we have a book. So this is our book that we have. It's seated on a flat table. How many forces do you think would be in the free body diagram of the book?
Just 2.
Just 2. Okay, let's identify those forces.
It would be the normal force and the force of gravity.
Yeah, so it's definitely going to be the normal force. So remember, on a free body diagram, we're only interested in the forces that are making contact with our object. All right, so there we are. So looking at the options that we have there, we've got 1. So we've already agreed that it's 2, but we've got 2 of the same type, 2 of the different types. 3 is already out. So are these of the same type or of different types?
Sir, can you please repeat that?
From the question on the options that we have on the screen, we've already agreed that we have 2 forces. Okay. Then the question on the options, we've got option B saying 2 of the same type, or C says 2 of different types.
Yeah, I think it's C, sir.
Yeah, 2 of different types, because they're not acting in the same direction. Okay, so let's move on to question 9 and look at some tension problems. So question 9 reads, a 4-kilogram block is suspended from the roof of an elevator. A 2-kilogram block is suspended from the 4-kilogram block. The tensions in the string 1 and 2 are labeled T1 and T2. So let's put our sketch. So this is 1, and this one is 4 kilograms. 4 kilograms, and this one is 2 kilograms, and this is the second one. And we have got tension T1 there, and we've got tension T2 here. Then what does the question say? use the following to answer the question. When the elevator accelerates downwards with an acceleration of 2.2 meters per second, the magnitudes of T1 and T2 are. So they're asking us to calculate the magnitudes of T1 and T2. So the best thing that we can do is to isolate this system into two cases, because we've got two masses or two objects that we have in that diagram or in that situation. So the first one that I'm going to write is for the first one, which is 1, where we have this. So this is our 4 kilogram. Okay. So let's identify the forces that are acting on this 4 kilogram body. So at the moment we are interested in this part. Let's identify the forces that are acting on this 4 kilogram body.
It is T1 at the top.
Going in which direction? T1 will be going in which direction?
T1 pulling the object upwards.
Okay. What else?
Pulling downwards.
Okay, T2 going downwards.
And gravity.
Okay, which is the weight of the body, right? Which is our mg. And in this case, we can just specify and say 4g, which is the same as mg, right?
Yes, sir.
Now, what are we told? In which direction is the elevator accelerating?
It's accelerating downwards.
Okay. All right. So our acceleration, remember acceleration is a vector. Is it going to be positive or negative?
It's going to be negative, sir, since it's going down.
Good. So it's going to be negative. So now we use our Newton's second law of motion. That is going to be the sum of forces is equals to ma. So let's sum the forces that we have. T1, if you make this origin, T1 is positive, right?
Yes, sir.
T1,
Going.
the weight is negative, so it's going to be minus 4g and minus T2, all equals to negative ma, because our a is negative, right? So this can be our first equation that we can that we have identified. This is our first equation. Now let's put a sketch for situation 2. Situation 2, where we have the 2 kg mass. So this is our 2 kg mass. Let's identify now the forces that we have. So now we are now dealing with the lower part. We're now dealing with this part. Okay, so let's identify the forces acting on that 2 kg mass.
It would be T2 pulling the object upwards, and
T2
gravity.
And gravity obviously going down. So these are mg, which is the same as
2g's.
2g. And again, we've already identified that our lift is going downwards, right? So our a is still negative. So let's form our equation. How is our equation going to look like?
it's going to be T2 minus 2G is equal to minus MA.
Minus MA. So this becomes our second equation. So now our problem is half solved. We're now looking at simultaneous equations, right? So
Yes.
obviously we'll start with finding T2 equals to negative MA, and our mass there is 2, right? So that becomes 2A plus 2G. So T2 will be the same as, we can factor out 2, so that becomes 2G minus 2A. So T2 will be 2G minus A. So that will be T2 equals to 9.8 minus A, which is 1.2. Am I right? No.
No, sir, it's 2.2.
2.2, thanks. 2.2. So we can punch that and see what we get. So that will be 2 bracket. So we get 15.2 newtons. So T2 is equals to 15.2 newtons. So do we have anything? T2, okay, yes, 15.2. all right, so we can then substitute our T2 in this equation. T1 will now be equals to minus 4G minus 15.2 equals to negative 4A. So T1 will now be equals to negative 4A plus 4G plus 15.2, which is going to be, factor out 4 becomes G minus A plus 15.2. So we can just say our answer plus open bracket 4 9.81 minus 2.2. We get 45.66. Alright, let's see if we have anything close to that. So 45.66 we don't have, so we've got 45.6. So our correct answer should be C, right? We agree?
Yes, sir.
That is what we got. That is what we are getting. So basically, once you identify the forces, your problem is half solved. Now let's look at question 10, which is the last question for the PHYV questions. Is it? Yes, because we also have to solve some questions for FEV, but the concepts are quite similar. So we have a question there. If a 5 Newton force, if F is 5 newtons, what is the magnitude of the force exerted by block 2 on block 1? So we want the magnitude of the force exerted by block 2 on block 1. So what do we do? What do you think we have to do first there, looking at that problem?
I think we first have to draw free body diagrams.
Okay, yes. So firstly, I'll just put it as it is. We have our 25 Newton, and this is our 1, this is our 2 kg, and these are in contact. this is 3 kilogram, and we have a force F. This is our block 2. Alright, so if a force of 5 newtons, if force F is 5 newtons, so we're given actually the magnitude of force F, it's 5 newtons. And we have another force that we have here, can you see? It's 25 newtons. And looking at the, which means we are supposed to still apply our Newton's second law of motion, right? Summation of forces is equals to MA. Because these are the two forces that we have that are being applied in the x direction. Do you agree?
Yes.
Alright, so 25 and 5 newtons is in the negative, so equals to mass times acceleration. What will be our mass? These two bodies are in contact, so that will be 2 plus 3a. So that will be 25 minus 5, that is 20, equals to 5a. So acceleration is equals to 4 meters per second squared. That becomes the acceleration of this system. In which direction?
It is going to the right.
Yes. So that is our A, which is 4 meters per second squared. Now, having done this, we need to find the force that is acting on the 2 kg body. So if we isolate our system to say, now we're looking at this part. If we were to sketch, this is what we would put. If we were to sketch, this is what we would have. This is our 25 Newton force acting on our 2 kg. And we're told that 2 is exerting a force on 1. So which means what will be the direction of the force? Is it towards 2 or away from 2?
It is towards.
Yes.
2.
So it will be towards 2. So, and this force, do we know its magnitude? We don't know. It's F2 on 1. And we know that this system as a whole has an acceleration of
4 meters per second squared.
Yes, 4 meters per second squared. So what do we do next now?
Don't we say that the sum of the forces acting on the object is equal to mass multiplied by acceleration?
So it's going to be 25
minus F2 on
1 equals to
2 multiplied by 4.
Oops. That is going to be the acceleration that we got, right? Which is 4 meters per second squared. So that becomes 25 minus 8 equals to F2 on 1. So that becomes 17 newtons, the force exerted on 2 on 1. Okay, do you agree with that?
Yeah, I agree.
Okay. Right, so that is what we have there. So that is what we have there. So this is what we had for questions on the PHY V101. So the rest of the questions, if you are interested in seeing how or having an appreciation how 11 to 15 you join in tomorrow's session, or watch the recording later on if you can't make it for the live session 11 to 15. So now we're going to be solving questions from the FPV. It's still the same concept but different set of questions, so you can still hang on. There are some very interesting questions that are there, so which can also add to your understanding on applications of Newton's laws of motion. So this is what we have done. So we'll start with this particular question. So it says, if the rocket sled shown in Fig 4.31 starts with only one rocket burning, what is the magnitude of its acceleration? Assume that the mass of the system is 2,100 kilograms, the thrust is 2.4 times 10 to the power 4, and the force of friction is known to be 6.5. So putting your free body there, we have to identify the forces acting. We've got the normal force, we have got the weight. What else do we have? We have got the frictional force, we have got the thrust going in this direction, right? So what is the question saying? What is the magnitude of the acceleration? So in the vertical there is no motion, which means that this acceleration that they're talking about is in the horizontal, right?
Yes.
So we have to sum the forces and equate to MA. So sum of forces equals to MA, and it's going to be our thrust minus the frictional force equals to MA. And what is our thrust? It's 2.4 times 10 to the power of 4 minus 650 equals to the mass 2,100, and we're looking for A. So which means our A, what's left there is for you to punch. So this is 24,000, right? Is it? It's 240 minus 650. Okay. Once divided by 2,100, we get 11.11. So our A is equals to 11.12 meters per second squared, which is the same with what we are expected to get there. So this is quite straightforward, right? Now let's look at this. Let's look at this one. The rocket sled shown accelerates at a rate of 4.9 meters per second squared. Its passenger has a mass of 75 kilograms. So this is our passenger. Calculate the horizontal component of the force the seat exerts on his body. Okay, so identifying the forces, we've got the weight, which is mg, we've got the reactional force or the normal force. Okay, and we're told that rocket sled, so it's moving in this direction with an acceleration of equals to 49 meters per second squared. So we're being asked to find the horizontal component of the force acting. So we're looking at the horizontal system, right?
Yes.
Yes, we're looking at the horizontal system. And as he is seated, there is no mention of frictional force between the seat and the person. So we're not told of any opposing force. So basically we're going to use F is equals to MA, and our F, we don't know our mass, it's 75 times our acceleration, which is 49. So what do we get? We get a force of 3, 6, 7, 5 newtons, which is the same as 3.68 times 10 to the power of 3 newtons. Right, then the question says we now have the horizontal force. It says calculate the direction and magnitude of the total force. So what do we have to do there? This is F in the X, which means to get total force, we need to combine F in the X and F in the Y. Is that okay?
Yes, sir.
And what is the F in the Y?
It appears to be 0.
Is it?
Yes, sir.
Let's see. Calculate the horizontal component of the force. Okay. We're not considering the person now. It says the what you call this? The seat, total force the seat exerts against his body. So mg is the weight of the person. But now we're not interested in the person. We're looking at the force that the seat exerts on the person. So what is the force that the seat is exerting on the person? The person is exerting a force of 75 G, and the seat is exerting a force of 75 G on the person. And the question says calculate the total force the seat exerts against his body. So what will be our F in the Y? From what I've just explained, would you like to comment again? Are you still there?
Oh, sorry. I was talking, but my mic was muted. I
Oh,
still
okay.
think that the forces on the y-axis will sum up to 0.
Okay, listen. Okay, let me try and explain again. Let's check what the question is saying. We're not looking at the resultant in the y. Okay, we're not looking for the resultant. It says calculate the magnitude of the total force the seat. So our reference is what? Is the seat. So if you look at the diagram that we've drawn here, remember Newton's third law, action and reaction. So the person is exerting 75 G on the seat. Then the seat is exerting 75 G on him. And our question now is saying consider the force that the total force that the seat exerts on the person, not the force that the person exerts on the seat.
So the total force that the seat exerts on the person is 3.68 kilonewtons.
No. This is in the X. This one is in the X. Now we want the component of Y, which is 75 G newtons. Remember action and reaction. If I'm sitting on a chair, if you're sitting on a chair, you are exerting a force on the chair. And the chair is exerting a force on you, which is the normal reaction. And this is the component in the Y. of the force which is acting on the person.
Okay, so I see it now.
Yes. So now to find the magnitude, now it's now going to be resultant being equals to 368 let me just say 3675 squared plus 75 times 9.8 whole squared. That becomes 3675 squared plus 75 times 9.8. That is the magnitude we get. 375. Okay. Did I do this properly? Alright, so which is what we have here. Then to find the direction, we all see that these are all positive, so they will lie in this quadrant. You calculate theta will be equals to arctan y over x, f in the y over f in the x. So that is how you find the direction. So you can always calculate this. You have been doing this a lot on vectors. Because of time, we're going to be having load shedding in 30 minutes time. So I want us to move on to another question. Where is that interesting question that we had? All right, just a moment. Just a moment. Okay, you'll be seeing my screen in a moment. All right, confirm if you can see my screen.
Yes, sir, I can see it.
Right, so we have two interesting questions that we were going to try and solve very, 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 very fast, because 25 minutes time is going to be load shedding. So let's try and work these out. These are very interesting questions, and I believe that they are going to be of interest. Right, so we have questions 6 and 7, so we're going to try and work them out, all of them, in the shortest possible time, shortest possible remaining time. So it says a contestant in a winter sporting event pushes a 45 kg block of ice across a frozen lake as shown in figure 2.1a. So this is the diagram of concern. Let me just try and make this bigger. Right. So it says A, calculate the minimum force he must exert to get the block moving. Right. And B says, what is the magnitude of its acceleration once it starts to move if the force is maintained? So you have learned about static friction and kinetic friction, right?
Yes, sir.
So let's put a sketch of what we have here. We have got this gentleman who is pushing. So this is our reference. This is going to be our reference. This is going to be our y. This is going to be our x. And this is 25 degrees. He is applying and pushing a force at that point. And we have to identify the forces that we have in that diagram. Definitely we're going to have the weight, right?
So
Which is going to be our mg. What else are we going to have?
the normal force.
We're going to have the normal force F, normal force N. What else are we going to have?
If there's friction,
Yeah, of
static
course.
friction.
Yes, static friction. In which direction? In the negative x.
Yes.
So Fs. Okay. And now we have to form equations in the x and in the y. Right. So in the x, we know we're still going to use summation of forces equals to ma, right?
Yes, sir.
So there's another force that we did not include there, which is the component of this force being resolved, right? This force F that is pushing at an angle of 25 degrees, right? Which means we're going to resolve it in the y, and we're also going to resolve it in the x. So this is going to be Fy, and this is going to be Fx. And if this system is going to move, we see the component of F in the x is positive and the static friction is in the negative, right?
Yes.
So F in the x minus the static friction equals to ma in the x. But what is the question saying? Is this body going to accelerate? It says calculate the minimum force he must exert to get the block moving. So to overcome static friction, the moment you overcome static friction, that's the moment at which the body starts to move. So at that instant, or just before that instant, the body begins to move. At maximum static force, what will be our acceleration?
It will be the acceleration. Won't it be 0 at that time?
Correct. So our a in x at this point is going to be a 0. So which means fx is going to be minus fs going to be equals to 0, which means our f in the x is going to be equals to our
Fs.
And this is maximum static force, because that's the instant at which the body is about to move. So this will be our maximum Fs, because it's about to move, right? All right, so we know that static force is equals to mu times n, right? So we have formulated our first equation. Are you okay so far?
Yes, sir.
Now let's look at the y direction. In the y direction. So in the y direction, let's look at the forces that we have in the y. We have got two forces going up, one force going down, so that is going to be our n minus, or we have to, is it n plus y? If we resolve that y, okay. Something is not proper with our y there. Do you notice? Fy.
It's not. It's supposed to be going down. So.
Yeah, it's supposed to be going down. Yeah, right. It's supposed to be going down. So f in the y, because it's on the negative side, so it's supposed to be going down. So these are f in the y. So n minus f in the y. What else? Minus mg, right?
Yes, sir.
Minus mg is equals to ma in the y. But as this object is being pushed on a horizontal surface, is it going to accelerate upwards?
No.
So therefore our a in the y is 0, right? So now let's equate. So this is going to be n minus f in the y. If you resolve f in the y, is going to be what? What would be the component of f in the y direction?
It's going to be sine.
So it's going to be f sine.
Yes, f sine 25 degrees.
F sine 25 equals to mg. So our n, which we are interested in, mg plus f sine 25. So we now have two equations now. Let's not forget, what are we asked to find? The minimum force. So our minimum force in the x, is that. So we come back to our equation. We are now going to put all this stuff in place of n. Do you realize that?
Oh, okay.
Yeah.
I see.
It's now like a simultaneous equation. This is our equation 2, this is our equation 1. And remember, we are looking for f in the resultant in the x direction. Okay.
Yes.
So this becomes mg plus f sine 25. So we now substitute. So in the physics workbook, FVV 101, they actually have a table that gives them the static coefficient of friction, which is 0.1. So in this case, I'll just give it to you, 0.1. What is our mass? It's 45, all right? So it's 45 bracket 9.8 plus, so actually this is just f now, plus f sine 25. Now we multiply, open our bracket. Where is my calculator? So that becomes 0.1 times 45 times 9.8. We get 44.1 plus sine 0.1 sine 25. we get our 0.04226 f equals to f. So that becomes 1 minus that, right? F minus 0.4226 f equals to 44.1. So that becomes
I can't really calculate, so the equations, I'm not sure where my calculator is.
okay.
So I think you made a mistake there by if that f is equal to 44.1 plus by 0.0, and when you wrote it, when you took it over to the other side, you said 0.4 instead of 0.04.
Okay, so if you multiply 45 by 9.8, what do you get? This is what I did. I said 45 by 9.8. Then I multiplied by 0.1. I get 44.1. So is 44.1 okay?
Yes.
Okay. Then this one, is it okay again? 0.1 times sine 25.
Okay. Let's see. But when you took it over to the other side, you forgot to. Yeah.
Okay. Thanks. So if we say now 1 minus okay, then we get 0.957 f 44.1. So we get 44.1. So we get an f which is equals to what? 46.08. Is that okay?
I do have a question though, sir.
But still we didn't get it right. We didn't get it right. The expected answer should be 51. Let's check again where we may have gone wrong. Oh, I think I see. This f, right? This f in the x, we forgot that we should resolve it. Do you realize this f in the x is this f in the x? We forgot to resolve it. It should reduce to f, because this is fx. It should reduce to f cos 25 equals to mu Sn. Do you realize that?
Yes, sir. I see it, sir.
That's how it becomes f. So which means we are supposed to come and change. We're supposed to come and change here, change the So So this is f cos 25, f cos 25, f cos 25, and this becomes f cos 25 minus that, so it's not just 1. So let's see, then we say cos 25 minus 0.04226. We get that right? Which then becomes equal to 0.864 equals to 44.1. And f, so f is going to be equals to 44.1 divided by that. 44.1 divided by the answer, we get 51 newtons, which they asked for. You got that?
Yes.
Do you understand how we solved the concept behind the problem, and do you understand why we had to correct to f cos 25? We had just identified that we are dealing with the horizontal direction, but we had then forgot to resolve in the x to get the horizontal component of that force F, which is F cos 25. Happy?
Yes, I do understand.
Great.
Very happy.
So if that force is maintained, calculate the acceleration. Then acceleration is just F is equals to ma, right? Ah, no. Hey. How then do we find the acceleration? Yeah, because this thing is not moving up, right? It's not moving up, it's moving in the x-axis. So we come back to our equation in the x, which becomes F in the x minus, but this object is now moving. We have to be careful of the friction that we put now. It's Fk, the kinetic, which is equals to ma, isn't it?
Yes, it is.
And our F in the x, it's F cos theta minus the the kinetic friction, which is mk times n, which is equals to ma in the x. This becomes F cos 25 minus mu, when it is moving, according to the data sheet, it's 0.03. Then what is our n? Our n, we did identify that our n is equals to mg minus f sine 25. mg minus f sine 25. This will be equals to ma. Then what do you do? Our f, we did identify our f. In place of f, you're now putting 51 cos 25 minus 0.03. Our mass is 45 times 9.81 minus 51 sine 25 equals to a all over the mass, which is 45. Let's see if we can punch that. 45. Times. Are you also punching?
No, I couldn't find my calculator.
Alright, so just check. I'm now rushing. Just check if I'm going to be punching correctly. And it will be load shedding any moment. But have you understood the concept? What is remaining here is just punching.
Yes, sir. And working with both the components of the forces and understanding which forces
yes.
Which and then having to work out the algebra.
Yes, yes. So
I just wanted to know, when are you going to be doing lessons? What is your schedule for making lessons so that I can attend?
So you mean online, right?
Yes.
So the tutorials, they run every Tuesday to Friday. Tuesday to Friday from 12 to 2. So on Tuesday there's Dr. James, then Wednesday there's Dr. Zola, Thursday there's me, then Friday there's Lucian.
Okay, so every day the lectures change.
Yes, yes. So every day the tutors change.
So I can attend every day.
You can, and you would benefit in attending as much as you can. Okay. Yes, so make sure you attend. Let me see did I punch this correctly?
Are they other students as well?
Sorry?
Are there other students as well who are attending?
They should, but unfortunately some don't attend the live sessions. Some will then watch the videos recording. At the moment on the Teams platform, I see that it's only you who is joining in. So other guys would prefer to, maybe they're busy with something else, they can't join in now.
Busy,
so yeah,
we're 1 minute away from the scheduled load shedding.
I see. And I'm getting 0.7 for
acceleration.
Yeah. Here we have 7.2. I'm not sure. I think maybe it could be